This lecture is going to go over oxidation reduction reactions. Um, so we'll start off with sort of a pictorial demo, and we'll look at a reaction between copper metal, which is shown here as a copper wire in our tube, and an aqueous solution of silver plus, which is really a silver nitrate solution, but that's really just to give us a source of silver cation, and that's what's in solution. You can see it's a colorless solution as shown there. And so when we look at that, we can see if we give this a little bit of time, what's going to happen is we see the formation of, first of all, a black solid showing up on top of the copper wire. And also notice the color of our solution is now blue. And so two things that indicate a chemical reaction has occurred. We see a color change in our solution, and we see the formation of this different colored precipitate. So the question is, what actually took place here? All right, so we know a chemical reaction took place. So what are the products of this reaction? And this is one example of our, and if we look at the products, what we see is we have copper 2 plus, and the blue color from the solution in the liquid comes from our copper 2 plus ions. And this silver solid is actually this black or metallic silvery looking compound that's precipitated out on the copper wire. So what's really happening is this copper, this metallic copper wire, is actually dissolving and changing into copper 2 plus, dissolving in solution and turning it blue. And the silver cation, which is in solution, is precipitating out onto the metal as copper solid. And this is our example of an oxidation reduction reaction, which are more commonly called redox, reduction oxidation reactions. And the key here with these reactions are that these are reactions in which one or more electrons are transferred between reactants. And so we already spent some time talking about oxidation state, and so that's a bookkeeping method of determining whether a redox reaction has taken place. So some definitions to start off when we talk about our redox reactions. A couple key terms to know is the thing that gains electrons, right? So this is electron transfers. So one thing is losing electrons, something else is gaining electrons. The thing that gains electrons is said to be reduced, and the thing that loses electrons is said to be oxidized. So if we come back to our reaction that we just looked at, copper solid goes to copper 2 plus. And here in this simple example, we can see we have metallic copper goes to copper 2 plus. And so if we looked at the oxidation state, we have oxidation state of 0 and oxidation state of plus 2. And so we can see copper is being oxidized. It's losing 2 electrons. The silver, on the other hand, is starting at a plus 1 oxidation state and going to a 0 oxidation state. And so we can see silver is being reduced and it is gaining 1 electron. Now, one really important thing to keep in mind is whenever you have a redox reaction, the total number of electrons lost has to be equal to the total number of electrons gained, right? Because it's the same process. So here we see we're losing 2 electrons, but we're only gaining 1. And so the way we're going to have to account for that, because those have to be the same, is through our coefficients. And so what we actually need to do is we have to put a 2 coefficient in front of our silvers so that the number of electrons lost must equal the number of electrons gained. All right. So whenever we balance our redox reactions, we have to take very careful consideration of the number of electrons lost and number of electrons gained. Now, when you talk about these terms, reduction and oxidation, what's reduced and what's oxidized, there's a couple good mnemonics to help you remember. One is oil rig. So that's oxidation is the loss of electrons, reduction is the gain. So oxidation is loss, reduction is gain. Oil rig. Another one, if you prefer, is Leo. The line says Gur, where Leo, losing electrons, is oxidation. The line says Gur, and Gur is gaining electrons is reduction. You may have your own, but those are two common ones that people find helpful. Another definitions that we should know, and these definitions can be confusing, are the oxidizing agent and the reducing agent. Now, the thing that's confusing is the oxidizing agent is the species that causes something else to be oxidized. So if it's causing something else to be oxidized, it does that by stripping it of electrons, making the other thing lose electrons, which means the oxidizing agent gets reduced. And the reducing agent, right, the reducing agent causes something else to be reduced. It does that by giving up its electrons to something else, and so the reducing agent gets oxidized. So those terms can be a little confusing, so take some time to sort of clarify that in your own head. So if we go back to our reaction, we can stop and say, what is the oxidizing agent and what is the reducing agent for this reaction? So you can pause the video, come up with the answer, and what you should have come up with now is copper is oxidized, and so therefore it is the reducing agent. Copper is causing silver to be reduced. Silver is reduced, and so silver is the oxidizing agent. Silver is causing copper to be oxidized. Now, some redox reactions are easy to recognize. So the example we showed is actually a fairly simple reaction to identify as redox, because we see something is changing oxidation state, going from 0 to +2, going from +1 to 0. So that's a fairly simple reaction to identify. Other reactions are harder. So take the case of this one below. Methane CH4 plus 2O2 goes to CO2 plus 2H2O gas. This is a combustion reaction. This is actually a redox reaction. And the only way we're going to be able to determine that this is a redox reaction is by understanding our oxidation states. And so if we look at this reaction in more detail, we can use our oxidation states to confirm that this is indeed a redox reaction. And so what I'd encourage you to do is pause the video and determine the oxidation state of all of the atoms in this, and then keep going with the video. So if you have assigned oxidation states now, what you should come up with is carbon is in the -4 oxidation state, hydrogen is +1, oxygen and O2 is 0, carbon on the right is +4, while oxygen is -2, hydrogen and water is +1, and oxygen is -2. And so when we look at this reaction and what happened, we can see that carbon lost 8 electrons. We went from -4 to +4, so we actually lost 8 electrons in the process. And oxygen went from 0 to -2, so each oxygen gained 2 electrons, right? So 1 carbon is undergoing change and 4 oxygens are undergoing change for a total of 8 electrons transferred. So here's 3 more examples. So again, pause the video and then determine the species being oxidized, the species being reduced, and the total number of electrons being transferred. So pause it, work through all 3, then keep going, and we'll go through the answer. So if you've done that now, we should come up with, in the first case, copper is +2, iron 0, iron 3 plus is +3, and our final copper is 0. So we have a total of 6 electrons being transferred, right? Each copper is gaining 2 electrons, but there's 3 coppers taking place. Each iron is losing 3 electrons, but 2 irons are undergoing change. In the second example, that's the one we just did in the previous slide. So we have a total of 8 electrons transferred. And then in our last example, we see that the iron starts off in oxidation state 0, oxygen starts at 0, and we go to iron oxide, rust, and we end up with iron in the +3, oxygen in the -2, and then we end up with a total of 12 electrons transferred. Thank you.